Kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. Memoization is the most over-applied idea in React, and the advice around it has genuinely changed, so this lesson has two jobs. The first is to explain what the three tools actually do, because they are simpler than their reputation. The second is to be precise about what the React compiler changes, because the short version people repeat is not quite right, and believing it will leave you with slow code and no idea why. Let me correct the framing on screen before we go further, because this matters. The React compiler is not something React 19 turns on for you. It is a separate build time tool, a Babel plugin you install and enable yourself, and it rewrites your components during the build to insert the memoization you would otherwise write by hand. Upgrading to React 19 gets you none of that on its own. Two consequences follow. If your project has not opted in, every rule about manual memoization still applies exactly as it did before. And this lesson's own playground has not opted in, which I checked. So what you are watching is ordinary unmemoized React, and that is the honest baseline to reason from. useMemo caches the result of a calculation between renders. You give it a function and a dependency array, and on each render, it compares the dependencies, returning the previous result if nothing changed and running the function again if something did. Same comparison mechanism as useEffect, different purpose. What it is for is a calculation that is genuinely expensive, sorting or filtering something large, or a derived structure that costs real time to build. What it is not for is adding two numbers, and the reason is that useMemo is not free. It stores the value, stores the dependencies, and compares them on every render. For cheap work, the bookkeeping costs more than the calculation. useCallback is the same idea applied to a function rather than a value. Every render creates fresh function objects. So a callback defined in a component is a different object each time, even though the code is identical. Usually nobody cares. It matters when that function is passed to a child wrapped in React.memo because the child compares its props, and a new function every render means the comparison always fails and the child re-renders anyway. useCallback keeps the same function object across renders so the comparison can succeed. Notice the shape of that. useCallback on its own does nothing useful. It only pays off in combination with something downstream that is comparing. React.memo wraps a component and skips re-rendering it when its props are unchanged. The comparison is shallow, which is the detail that decides whether it works. Each prop is compared by identity, so a string or a number compares fine, and a freshly built object or array or function never does. That is why memo and useCallback are usually discussed together, and why wrapping a component in memo while passing it an inline object achieves precisely nothing at a small cost. Worth adding what memo does not do. It does not stop a re-render caused by the component's own state or by a context it reads. It only stops the one caused by its parent rendering. The list on screen is good and the principle behind it is better. Every memoization has a cost that is paid on every render and a benefit that is only collected when the thing it protects would have been expensive. Cheap calculations, components that render rarely, values that change every time anyway. In all of those, the cost is the only part you get. There is a second cost that is harder to see and worse in practice. Memoized code has dependency arrays, and dependency arrays go stale. A bug where a callback closes over an old value is much harder to find than a component that renders more often than it strictly needed to. The advice on screen is right, and it is worth being clear that it is the same advice as before the compiler existed, only stated more confidently. Start with none of it. Write the straightforward version and use it. If something feels slow, measure it with the profiler and find out which component is re-rendering and how long it takes. Then memoize the specific thing the measurement pointed at and check that the number moved. If your project does enable the compiler, that changes the default rather than the method. The compiler handles the routine cases at build time, and you are left doing this deliberately for the ones it cannot see, which is a smaller list but not an empty one. useMemo caches a value, useCallback caches a function, React.memo skips a re-render when props compare equal, and all three use a shallow comparison you should be able to picture. None of them is free. The compiler is an opt-in build tool, not a React 19 feature, so check whether your project actually has it before assuming anything. And the order of operations never changes. Write it simply, measure, then memoize what the measurement identified. The playground here is a single file, so read it as one worked example rather than a before and after. It builds an expensive calculation, wraps it in useMemo, and passes a callback down to a child that is wrapped in memo. Follow the three pieces and how they connect. The memo on the child is what creates the need for the use callback, because without the memo, nothing is comparing props and a fresh function. Every render costs nothing. The use memo protects the calculation, and its dependency array is the list of things that make the previous answer invalid. Try the experiment the file invites, take the use callback off, and watch the memoized child start re-rendering again because its function prop is a new object every time. That is the clearest demonstration there is that these tools work as a set, and that any one of them alone is often just overhead. The model to keep has two parts. Memoization is caching, so it trades memory and a comparison for work you would otherwise repeat, and it only wins when that work is real. And the tools compose memo does the comparing, use callback, and use memo make the comparison capable of succeeding. Before reaching for any of it, measure. After reaching for it, measure again, because the most common outcome of memoizing by instinct is code that is harder to read and exactly as fast. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.